Hi everyone, I'm Sharmini and my team Erika, Chelsea, and Fee. Together, we have designed a database for a disaster relief and emergency response, a centralized system built for monsoon season floods in Selangor. During monsoon season, flood response in Selangor faces a major challenge because the coordination is manual and fragmented. This makes it hard for authorities to track what really matters, such as affected households, victims, shelter capacity, volunteers, medical teams, and aid supplies, all in real time. And because floods are recurring, not isolated events, we can't rely on temporary fixes. That is why our main goal is to develop a centralized database, one that improves response speed, accuracy, and coordination. Ultimately, this system is about two things: ensuring timely assistance and enabling fair distribution of resources to those who need it the most. Our chosen scenario focuses on monsoon season flooding in Selangor because during these floods, many households are displaced, relief centers become overcrowded, and there is a high demand for food, medical care, and volunteer support. This system is designed for use by NATMA, local authorities, relief center staff, volunteers, and medical teams. It supports key operations such as incident tracking, managing evacuation, and coordinating aid distribution to ensure assistance reaches affected communities efficiently. This slide explains how the system addresses the flood response challenges. The database is designed to model real world flood operations, including incidents, victims, households, relief centers, volunteers, and aid. By centralizing all this information, the system enables faster decision making and more accurate tracking of both people and resources. As a result, it reduces aid wastage, prevents volunteer mislocation, and minimizes data inconsistency and leading to a more efficient and coordinated flood response in Selangor.
Hi, my name is Chelsea and I'll be explaining the business rules. To start off, we begin with the incident entity which serves as the triggering event for all response action. An incident is defined by its scope. It may affect zero or many households depending on the severity. And every incident must be linked to exactly one district, and it may require zero or many medical team assignment for response. Next is the district entity which represents the administrative states of Selangor. The district acts as the parent entity as it records zero or more accidents over time. A key requirement here is that every district must operate one or more release center to ensure readiness. Moving on to the release center entity, which is a physical hub for injured victims. Each center belongs to a specific district as it coordinates zero or many volunteer assignment and conducts zero or many aid distribution. And lastly, accommodates zero or many evacuated system, and lastly, holds zero or many medical team assignments. We then have the household entity, which is defined as a unit of victim receiving support. To maintain data integrity, every household must be linked to exactly one specific incident. A household may consist of zero or many victims, and it is the primary recipient of zero or many donation. And this brings us to donation entity, which tracks financial aids or gifts. The rule here is simple and strict. Each donation record must be assigned to exactly one household. Here is the next portion of the business rule table. We have the victim entity representing the affected individuals. Each victim must be linked to one household, and a victim may or may not be evacuated, may have zero or many medical records, and can receive zero or multiple aid distributions. Next, we have the healthcare workforce, which consists of medical teams. They may handle zero or many medical records and receive zero or many assignments. On the record side, each medical record must be assigned to exactly one team and one victim. And other than that, every medical team assignment is strictly linked to one incident and one release center. Following that is the general workforce, which is volunteer. A volunteer should be recorded in one or many assignment records. They are also responsible for facilitating zero or many aid distributions. And every volunteer assignment is linked to exactly one volunteer and one release center. Finally, we have the resources. The supplier entity are expected to provide one or many aid packages. These packages, once obtained from a single supplier, can be distributed in zero or many transactions. And to ensure accountability, every distribution is tied to exactly one specific aid package type. The key rule here is that the aid packages are distributed to a victim at release center by a specific volunteer. And in conclusion, by following this business rule, we create a single accountable system for effective disaster response. This ensures that every resources is properly distributed, every task is clearly aligned, and every victim is accurately tracked throughout the crisis. Moving on to constraints, we use constraints to ensure our database maintains high data quality as we enforce strict standardization constraints across these three key areas. First, we have consistent pattern. We implemented consistent naming patterns for all our primary keys. For example, every victim ID must start with the letter V and every release center must start with the letter RC. This makes the data easy to identify and recognize. Second, we have data formatting where we enforce strict formats formulation contact numbers, such as the system must follow the format 0% dash percent, and for gender, it must be recorded as either M or F. And this ensures all entries in our database are the same. Finally, we have data validity where we apply logical checks to block impossible data such as negative age or future dates. For example, for volunteer age, we only ensure that they are between the age of 17 to the age of 120 and that quantities cannot be recorded as a negative number and records can't be dated in the future. By doing this prevents invalid data before it enters the system. Moving on to constraints where we apply business logic and specific rules. First off, we have standardized status tracking where we restrict data like victim status to a predefined list such as rescue or missing. This prevents random text entries. Second, we have clear classification and role where we enforce strict categories for volunteers, ensuring, for example, that a logistic volunteer is never accidentally assigned to a medical task. Third, we have risks and priorities where we standardize how we prioritize aid and responses in areas such as severity level and risk level. Finally, we have mandatory information where we apply not now constraints to important data such as house addresses and team leaders. This ensures that very important details that a disaster management system must have and cannot function without. Next, I'll be explaining the examples of ordinality used in our ERD diagram. First, we have the first image on the left, which you can see for donations, the ordinality is 0, which means that some households may not receive donations while other households may receive multiple donations. As for the middle image, if you look at the incident entity, you'll see the ordinality is 0, which is indicated by the circle symbol. This means that the relationship is optional. And to further explain what that means, it means that a district can exist in our database as a location, even if 0 incidents have occurred there so far. And it is possible to record an incident that currently impacts 0 household. Lastly, for the image on the right, you can see that a victim is linked to a household, but their evacuation status is optional. By doing this, this allows us to track regardless of whether they are sheltered at a center or decided to stay home.
Hi Miss, I'm Erica Manshen and today I'm going to share about 3 queries that included auto join, group by function, string pattern, and date function. This is my first query and this query lists all victims and shows their evaluation dates if available. And auto join is used so that victims who have not been evaluated are still included in the result. This SQL code lists all victims and their evaluation dates if available. A left join is used to ensure that victims who have not been evaluated yet are still included in the result. This is a useful identifying victims who still require evaluation assistance. This is a second query. This query has count the total number of incidents and victims for each district by joining 4 tables and grouping the data by district name. The SQL shows each district along with the total number of incidents and the total number of victims. This is the third query, and this query finds victims whose first name start with a specific letter and who were born within a selected date range. And this query finds victims whose first name start with the letter S and who were born between 1990 and 2000. The like S condition is used for string pattern matching. The toDate function converts text into date format. The between keywords filters within a specific date range.
Hello, Miss. My name is He Hui Yu. Today, I'm going to share about three SQL queries based on a disaster release management scenario, also with the SQL code and the results. The queries include logical operators, subqueries, and aggregations functions. This query shows how N and O are combined to filter warranties based on release centers, warranties role, and their age distributions. In this slide, we use N to combine center conditions and warranty types. Next, we use O to filter the warranty whose type is either logistic or support, and similarly for the release centers. We also use group by and having to count total age distribution for each warranty. This query shows how to find the victims who receive the value of a package or donations more than 300. In this slide, the SQL code shows that we use subquery to calculate total donations per house and total aid package per victim, and also use all conditions to find those more than 300. Lastly, this query helps to find the release center with the highest number of aid distribution and the most frequently assigned warranties in the 3 past months. In this slide, show that we can use count to get the total of aid distribution and warranty assignments so that we can know the highest one sorted by descending aid distribution and warranty assignments per warranty in that centers. The row 9 only show the top performing centers after sorting the arrangement. Overall, this query shows several SQL methods to support decision making in a disaster release system. In conclusion, our project aims to design a database system to manage flood incidents efficiently. The ERD was designed to avoid a normalized through proper normalization and well-defined relationship. The SQL query show how the database can effectively retrieve important information. Besides, through teamwork and discussion, we are able to identify design issues, prove the database structure, and complete the project successfully. Here is the end of our presentation. Thank you.